Working with arrays. Let us understand what is an array. An array can be defined as a collection of homogeneous elements, meaning that all the values stored inside an array are of the same data type. Also, they are stored under a common name, which eliminates the need of declaring separate variables. And finally, these are stored in consecutive memory locations. Suppose that we are given a set of 5 integer values like this in our program and we want to process them in some form. Then what would be the most convenient method to store these values? Well, it's very simple. We can declare separate variables and store these values individually. This method works fine if we are given a smaller set of values. But if we are dealing with a larger set of values, then this method is definitely not recommended. Whenever we are dealing with a larger set of values of the same type and we are processing them at the same time, then we can use arrays. Let us see the syntax of declaration of an array. The syntax is very simple. We have to first mention the data type of the array, then we have to supply the array name according to the rules of the identifiers, and inside the square bracket along with the array name, we have to mention the size of the array. This size indicates how many elements we can store inside the array. Initialization of an array is also a straightforward process. Here again, we first mention the data type of the array and then we supply array name along with the size of the array inside a pair of square brackets. Then we put an assignment operator, and finally the values that we want to store inside our array must be written inside a pair of curly braces and they must be separated by comma operator, and finally we terminate this entire statement with a semicolon. So here is an example of an array of integer type. The name of this array is marks and its size is 5, meaning it can store 5 elements. The order in which I have mentioned the values is the order in which values get stored inside the array. Therefore, 19 will be stored at default position of 0. This is the index value 0. Similarly, the second value of 20 will get stored at index 1, 78 at index 2, 34 at index 3 and 56 at index 4. Inside the memory, these will be stored by the compiler in consecutive memory locations. You can create arrays not only for integers but also for floating point numbers and characters. Here is another example of an array of floating point type. The name of this array is price and its size is 4. So the first value of 180.75 will get stored at index 0, the second value will get stored at index 1, the third value at index 2 and fourth value at index 3. Once again, these values will be stored at consecutive memory locations by the compiler. All the elements inside a one-dimensional array are accessed using index values. The syntax to access an individual element of an array is quite straightforward. We just have to mention the array name, and inside the pair of square brackets we have to supply the index or the position. In this program, I am going to create an array and store some values inside it, and then I will display those values. These values of an array are called as elements. So first of all, we will type here hash include iostream. Then in the next statement we have using namespace standard. Then we will type here int main, and inside the main function I am going to declare my array. Let us suppose that my array is called as marks. So the name is marks and its size is 4, and I want to store 4 integer values inside this array marks. So the data type of this array will be int. And now I will assign it some values. So I will have to type here an assignment operator like this. Then I will put a pair of curly braces, and now inside these curly braces I will store my values like this. So let's say my first value is 22, next is 34, then maybe next one is 39 and then 40. After this I will put a semicolon at the end of this statement. So in this step I have created an array and initialized it at the same time. This means we are storing the values inside the array. Now I want to tell you that even if we skip the size of the array within these square brackets like this, then also this program will work fine, and the compiler will be automatically able to store these 4 values inside computer's memory. So it will reserve space for these 4 integer values inside the memory, even if you skip the size of the array. Let us now talk about how much memory space is required to store this array. So memory space for an integer array will be calculated like this. We have size for one integer value, which is equal to 4 bytes multiplied by number of elements of the array, which is in this case again equal to 4, because the size of this array is 4. We have 4 integers, so the result is still 16 bytes. So this much memory space is required to store my array inside the computer. Now I am going to display each of the elements here. So I have written cout, and inside these double quotation marks I will type element 1 is equal to, and in order to access any element of an array we have to type the name of the array, and then we have to put a pair of square brackets, and within these square brackets we have to provide the index of that particular element. I want to access my first value, which is by default stored at index 0 inside the computer system. So here I will type 0, and similarly I will type here cout/n element 2, and the index for this will be marks 1, and same thing I have to do for the rest 2 values also. So here element 3 will be at index 2 and element 4 will be at index 3. So once I am done typing these statements, I will type here return 0, and let's save this program as array1, save, and now run it. So you can see here element 1 is 22, element 2 is 34, and similarly the rest 2 values have been displayed from the array. Now let us suppose that instead of supplying 5 different integer values, I supply only 3 values. Then what will get stored at those empty positions at index value 3 and 4? Can you think of it? Well, the answer is that when we supply no integer value in case of an integer array, then the compiler automatically stores 0 at those empty spaces. Suppose that for my array price of floating point type, instead of supplying 4 different floating point type values, I supply only 2 values. Then what would happen? Well, obviously my first value of 180.75 would be stored at index value 0, and the second value of 545.30 would be stored at index value 1. But what about the other 2 locations? In that case, the compiler would automatically be storing 0.0 as the default value for these empty spaces. Individual reassignment of values in an array is also possible. Let's see an example. Suppose I want to change value 39 and I want to make it 50. Then in order to do so, I will type here marks, and then I have to provide the index of this value, which is equal to 2, since it is the third value, and let us assign it some new value, say 50. And now I can again display all these values, and I will show you how this change affects the array. So here I am typing one statement. So here is the output, and you can see here that the value 39 has now been replaced with value 50. So this is how you can change any value inside an array. This process is called as reassignment of array elements. If we want to get access to all the elements of an array for the purpose of reading or writing, we can use a for loop. In this program, I am going to create an array and display all its elements using a for loop. So as always, I have written the basic structure of the C++ program, which is #include iostream using namespace standard, and the main function is also written over here. Here I want to have a floating point type array. So the data type of this array will be float. Let's call this array as ARR. You can name your array as anything as you like according to the rules for identifiers. And let's say the size of this array is 5. I want to have an array of floating point type with size 5. And this is it. The declaration is now over. Now I haven't initialized it because I want to get the input from the users. So I want to store all the values inside the array one by one, and for that purpose I have to keep track of its index, because I have to begin from index 0, because that is where the first element is to be stored. So here I will have a loop variable which is also acting as the index variable. So int I, and this variable will keep track of all the indexes inside the array. Here I will type one statement /n enter array elements, and then I will declare my for loop. So here for loop, and inside this for loop I will have index value I. We know that if the size of the array is 5 and the index of the first element is equal to 0, so the last position will be 4. So my I value will begin at 0, and then it will go from 0 to 1, then 2, 3 and 4. So all the values are either less than 4 or equal to 4, and this is my conditional statement. And here I will type I plus plus, and then I will type my loop body. Now inside this loop body I will ask the user to enter element at index, and then I will display the index value, and here user will enter something. And in order to get the input from the users, I have to type cin and then the name of the array, which is ARR, and I want to store my first value at index 0, then at 1, then at 2 and so on. So here with the name of the array I have to put one square bracket, and this index value will be updated by for loop. So my index value will get stored in variable I. Okay, so this part is for input, which is over. Let's save this program as array2, and once I save it, let's run it. So enter array elements, enter element at index 0. So I have to provide a few decimal point numbers. So let's say 12.53. Enter element at index 1, say 34.57. At index 2, maybe 300.00, then maybe minus 140.89, and finally at index 4, 56.7. And this is how I will be getting input from the users. So the first part of the program is over, which is to create the array, and we have already stored all the elements. Now comes the second part, which is to display all the elements one by one. So here I will be typing one statement once again. Array contains the following elements, and after this a semicolon. Again I am going to use the same for loop. Again I will begin from index 0. I will go up to index 4 and I plus plus. Inside the loop body I will be displaying only, no input is to be taken, /n element at index, and then I will display the index value. And once again I have to access the array elements, so here I will type ARR I, and that is it. Let's rerun the program. So here you can see, first of all we have to provide the input. Any random values can be entered. We just want to see whether the program is working fine or not. and finally I provide my last value. So as you can see, all the elements along with their index numbers are now displaying on the screen.